All right, we're going to go ahead and get started. Welcome to today's CNCF webinar, Role-Based Access Control, that's RBAC, Policies in Kubernetes. I'm George Castro, Community Manager at Heptio and a CNCF Ambassador. I'd like to thank everyone who's joining us today. We'd like to send a welcome to Javier Salmeron, Computer Engineer at Bitnami, who will be our presenter today. We appreciate his expertise on access control policies in Kubernetes with our listeners today. Some housekeeping items before we start. So during the webinar, you won't be able to actually talk through the meeting. So there's a chat window at the bottom of your client, or you can use the Q&A function. Click on that and you'll be able to drop your questions in there or in chat, and we'll get to as many as questions as possible before at the end. The session is going to be recorded, and we'll send along a link to that recording and a link to the slides from the presentation. And with that, we'll hand it over to Javier, and let's go ahead and get started.
Thank you, Jorge. So, hello everyone. Thank you for joining this online talk. So, yes, today we're going to talk about RBAC, role-based access control. I remember when it was like maybe 1 year ago that when working with Kubernetes, suddenly there was one point where everything seemed to be relatively easy to work with, and suddenly RBAC came, and forums, Stack Overflow, everything started to appear with, it was like a nightmare, because suddenly when these policies were enabled by default, it looked like nothing worked. And so I think things have changed a little bit, but I think it's worth taking a look and trying to understand the concepts that are behind this. Actually, it's not that difficult as it may seem, even though I know that several people may have many troubles with them. But I want to keep it as simple as possible, as intuitive as possible, so we get to understand the core concepts. I have some slides, but I will also go to the console to show some RBAC policies in action. So, okay, so with that said, the way that I want to start is with a really simple thing that we may want to do in a Kubernetes cluster, which is creating users, because I think that's the perfect way to start. Because I can imagine that several people of you that have played with Kubernetes, have worked with Kubernetes, especially Minikube or KubeIDM or Kubernetes Sandbox from Bitnami, may have deployed several applications, may have worked with Helm, probably will work with Helm as well here. But I'm sure that many people have used all the full administrator credentials. That's the default credential, for example, with Minikube, which means that you can do pretty much everything inside the cluster. But if we talk about, let's think in our companies that if we want to use Kubernetes in production inside our companies, for example, in Bitnami, we may want to have something a bit different. We don't want to have users to have full privileges, and because it will be something, or to have just one account with full privileges. We may want to have like different types of users. We may want to have different groups, different operations that each one can do, so we can have some sort of control. So in this session, we're going to put ourselves on the shoes of an administrator, and we want to try to have our cluster with different types of users. In this sense, I think that when studying Kubernetes, we know that one of the advantages is that pretty much everything, almost everything, is modeled as an API object. So one may think, oh, so then it may be the same for users. So there might be a kubectl create users, just like we do kubectl create deployment or create pods. But the thing is that, unfortunately, that's not the case. So we don't have a kubectl create user that would allow us to just configure everything. Because in this sense, for users, Kubernetes provide no API object in the sense, that's why they start, just like we have with pods. So there's no user object that can be created, deleted, updated, or read. So what's the alternative? In this sense, Kubernetes relies on the cluster administration to have that set up. So the Kubernetes will rely on something, let's call it externally, in this sense, external entity that will configure everything about user authentication or user management. So there are different options in this sense, as certificate-based authentication, using tokens, using basic authentication with username and password, or OAuth2 and other options. For this online talk, I will just go for some basic option, which is the certificate-based authentication. So we have our cluster, and I have a Minikube cluster that I will show you, and I'm going to try to add users using certificate-based authentication. So let me go a bit further on that. So basically, the idea that you need to know about certificate-based authentication in Kubernetes is the following. When you create a cluster using Minikube, or you deploy yourself using GKE or wherever, the core idea is that there is one certificate authority in the cluster, comprised of a public certificate and a private key. This authority, why do we use this authority? We're going to use this authority basically to create certificates that will be accepted by the Kubernetes API. So if we want to create a user with their certificates, with a private key and public key, this certificate will sign it, and therefore, if you want to access Kubernetes, your cluster, using this certificate signed by this CA, Kubernetes will accept it. As long as it's signed by this CA, everything will work. So in order to create to create the user certificates, we can and also the certificate authorities, but in this case are created, we can use different solutions. For example, OpenSSL or the Cloudflare PKI toolkit, which is used in a very well-known guide, which is the Kubernetes the hard way, to build your own cluster. But in this session, we're going to use OpenSSL, which is widely available in all Linux-based operating systems. So I think that's one of the easiest choices. And when creating this user certificate, I don't know if you have some experience with dealing with OpenSSL, but in this case, we only need to take into account two fields when creating the user certificates. One is the common name, because Kubernetes will interpret this value as the user, and the organization, because Kubernetes will interpret these values or set of values as the group. So just to summarize again, so Kubernetes has no user object. Instead, will read the values from the user certificates, which will be signed by the cluster authority. So as you can see, that information, that user and group, it's outside of the cluster data. Well, so that's the idea. So we're going to create certificates. And how is this process? Really simple. I'm going to go really simple to the steps. So let's imagine the developer, the one that we want to grant access to the cluster, basically will create a private key in their local system and will create a certificate sign request. This request will be sent to the administrator and it will be signed in order to create the certificate for this developer, called Juan in this case. This is the command. I don't want to go much into the details of the command. It will be available in the GitHub repo with the samples. But notice this part, the common name, which is the username, and the organization, which is the group. That's what we need to put as the data in the request. Then we'll send the certificate to the administrator, and now the administrator, it has access to the cluster authority, will just sign this request and generate the certificate to the user. So the user created a private key, a request, and then the administrator creates the certificate for this user. So once we have this certificate, there's one extra step missing, which is to configure our client, kubectl, to access the cluster with these credentials. Basically, that's done using the kubectl command and the context. So what we do is to get our certificate, so our private key, which was locally created, and the certificate, which was generated by the administrator. And with that, we create the new information in our Kubernetes client configuration, which is called context, which is just plainly simple. Which cluster I'm going to connect to, and with which credentials we're going to connect to the cluster. So first, we add the information about the Kubernetes cluster that we want to connect to. Basically, we put a name, we put the public authority, and the address of the cluster, basically, and then we add the credentials to as well. So we're adding a new user with this private key that we created before, and the certificate that was created by the administrator. So with that, we have a cluster, we have a credential, and finally, we need to link the two of them using the context. So we're saying that we're going to connect to this cluster created above with these credentials there. So that's the basic idea when we want to add users. So now with this, I'm going to show it really fast how to do it. This is available in the GitHub repo. You can see it in the slides. Basically, I'm going to go really fast with these commands. So I got a Minikube running here, machine. I just created it, and basically, I'm going to go through the steps. I'm going to create a folder with where I'm going to store my certificates. I'm going to create my private key, and I'm going to create a request for the cluster administrator. So in this request, I'm just putting, which is my common name, so my username, and the groups that I belong to, because I decided these groups, because this for a better organization. Basically, I wanted to create this group, but you can create whatever groups you consider proper. That's something that the administrator will decide, or your team. So I'm going to create a request, and now I'm going to switch, because now I'm the developer, the one that is requesting. Now I'm going to turn into the administrator. So now the administrator will take that CSR and will sign that request using the cluster authority. In the case of Minikube, is inside this, the .minikube folder. And basically, what we do is sign it. And now in this folder, I got all the information that I require. So, yes. So I got my private key and my certificate. If we use OpenSSL to look into the contents of this certificate, we can see a lot of data, but here is one of the important bits of information. The certificate was signed by Minikube, the authority of the Minikube cluster, and with this information. This is my common name, username, and my group. So now that I have that, I'm going to basically configure kubectl to access my Minikube cluster. In this case, I don't need to add the information about the cluster because it's already there. Because if I do kubectl config get clusters, you can see that there's already the information about Minikube in my client. If not, you will have to add it. So I only need to add the new credentials to my configuration. So basically, I'm adding my client certificate and my private key. And finally, I'm just adding this new context to my cluster, to my kubectl configuration, which I say, which cluster I'm going to connect? Minikube. Which credentials? The one that I just created above. So that's it. Now, if I execute this command, which is kubectl config at context, now I can access my Minikube cluster in two different ways. Using my administrator credentials, the one that we normally use, and now another user called J Salmeron, which is with the new certificates created. So now when I access the cluster, I will be able to access as the administrator of this new user. So if everything's ready, I'm going to just try it and see what happens. Now I've become the newly created user, and I'm going to do the most simple operation that most of everyone that has learned Kubernetes has tried, which is to get pods. And this is what I get. So as you can see, I get an error saying that user J Salmeron cannot list pods in the same namespace default. What's happening here? So the thing is that, yes, we've created a user, but we haven't said what kind of operations this user can do. So by default, this newly created user can't do anything, and it makes sense. If we want to make it secure, first you will create the user, and then you will decide what this newly created user can or can't do. Makes sense, right? So because if I go back to the other administrator credentials, of course, I can access and get the pods. So this is the part that introduces us to RBAC. That's the way I wanted to start. So we create a user. We know now how to create a user. So now we can create multiple users, and now we're going to learn how to define what a user or a set of users can or can't do. So I'm going to skip, this is the testing part that we've seen. And now let's start with role-based access control. When it comes to RBAC, there's three basic things that we need to understand. Three basic elements that we need to understand in Kubernetes and in other RBAC-based systems. We have what is known as subjects. This is a set of users, right? We created one. We've got human beings. We can have processes in an operating system, processes in a pod, but that's why we call them subjects. So we got users. That's something that we already created. Then we have something that we already know from experience with Kubernetes: resources, pods, deployments, services, config maps, Ingresses, rules, wherever. So we got subjects and a set of resources, and we have a set of operations that we can do over this set of resources. So we can get pods, we can create services, we can list, watch, delete. These operations are called as verbs. So we have these three groups. So what does RBAC do? It's just connect the three of them. So with RBAC, we're going to decide this: one developer can get pods, for example. So we need to connect these three groups. Well, with this idea in mind, that's what we're going to do. And Kubernetes offers us API objects with that objective: to connect subjects API resources, and operations. So let's go to the right-hand side of this, to these two groups first. The first object that we have in Kubernetes for RBAC is the role. What does it do? It connects resources and operations, but inside a namespace. So what we do is to define a set of operations that we can do over a set of resources inside a namespace. So notice these three elements: so operations, resources, and namespace. So what we do is just to select, for example, pods and list and get as operations, and we create a role that connects the two of them, for example. Another example, we may want to do everything with every object inside a namespace, right? So that will be another role. That's the main idea, to connect resources and operations. So this role, what's the YAML? Let's go and take a look at the YAML. So as always, we have kind, API version, metadata. That's something that appears in every single Kubernetes API object. And then we have a section called rules. And what do we define there? Basically, which resources and which operations. So resources and operations, once again, it's just a connection of the two. So basically, in the which resources section, we need to specify a name of the resource and the API group it belongs to. As we may know, Kubernetes offers different API groups, and there are different API objects inside of them. So how do I know the name of the API group? That's easy. You only need to go to the API reference and take a look. So if you go to this link, you'll see something like this. So for example, for the rule that I want to create with is to be able to get pods. So I will go and say, okay, pod, this is the name of the resource, and the group it belongs to is core. So I will, in principle, I will put name and core, but in the case of the group core, we don't put we use the empty string. But for example, if we wanted to use deployment, we will put apps here. So there we have resources, pods from the core group, and then with operations, we put it like that in the section verbs. So that's it. We said we got resource pods and the operations get and list. For the other example, we can, for every resource and all the operations, we can use wildcards, for example. This is the other example that we have. Well, so we've connected two of the elements of the groups. Now we're missing the other one, right? Users, subjects. So how do we connect with subjects? We have now a set of roles which connect operations and resources, and now with role bindings, we're going to connect a role to a set of subjects, a set of users. For example, we may want to say all these users from the group dev, for example, that's why groups are useful, can read pods. So we're connecting the role with this set of users. And the other role, which have more privileges, we may want to say, no, this one, we only want to connect it to this specific user. That's what we're going to do with role bindings. So what's the YAML of the role binding? It's just the same. We got the kind API version metadata, and now we're going to specify which subjects we're going to apply a single role. So we're going to put below our role, and we're going to put a set of subjects above. Basically, in the subject section, we can put a user, a group, and another one that we'll see later on. But for what we know right now, users and group. For example, in the case of be able to read pods, we can use the group devs. And we specify as well the API group, this where we can find the object group, but it's not an object like deployments and pods. It's an API entity different. That's from the subjects, and now below we put the role we want to apply to that group of subjects above, and it's just the same. So role and a pod and the API group. So with this, we've connected users, resources, and operations, and I'm going to show it right now. So let me go back to the terminal, and let's go to the second section. So basically, we have, before that, that we weren't able to access pods. So let's go. What we're going to do is to allow this newly created user to access pods, but first only in a specific namespace. So I'm going to create the proper rules so this JSON Veron user can access pods inside that the namespace test. So in order to do that, I'm going to switch to admin. I'm the cluster administrator. I can create the rules, and I'm going to create the namespace test. With that, I'm going to apply these two YAML files, which are basically what we've seen before. The role, the pod access, so giving us, I can get and list pods inside the namespace test. So I'm going to just deploy it. And I'm going to, as well, add the cluster, the role binding as well, just like we've seen before. So this newly created role, we're going to make it available to the group devs. And as we previously saw, we saw that this user, JSON Veron, belonged to the group devs. Why? Because that's how I wanted to do it as the administrator. Well, so I'm deploying this to rules. And now, if I switch to my new context, if I try kubectl get pods, it will not work because it's accessing the default namespace. But if I try to access the test namespace, you can see that I can. In this case, there are no resources because there are no pods deployed. So I'm going to try that. I'm going to try to deploy an Nginx in this new namespace. But I can't. Why? Because the only privilege that I have is to get the pods, but I can't create a deployment, I can't create services. That's the only thing that I can do at the moment. So in order to continue, I'm going to now grant me the access to do everything inside that namespace. That's the other role we saw. So I'm going back to being the administrator, and now I'm going to deploy the other two roles. The one that could do everything inside test, and to which user? To myself, basically. So I don't think I showed it before here, but basically that's the role binding. Basically, I'm saying that this role, that set of operations, which is to do everything, will be connected to the user JSON Veron, which is the one that I created. So now with that, I'm going to deploy these two roles. Now got the role, the set of operations, and now the binding. And with that, now, in principle, as the user JSON Veron, I can do everything inside the test namespace. So now, if I try to deploy, for example, an Nginx, now I can do it because I have the proper privileges. So I got the proper set of operations connected to my subject, which is JSON Veron, basically. And there it is, creating the container. But what is more, I can, for example, create services. Why? Because I can't do everything, as I said before. I can see the services created inside that namespace. But just like before, I can do everything inside the test namespace, but not in other namespaces. In the default, I still have no privileges at all. So as you can see, that's the way that we can start defining what a set of users can or cannot do inside our cluster, Kubernetes cluster. Let's go a bit further with this. So, okay, fine, I'm able to define what a user can do inside the namespace, but what if I want to be able to define privileges that are not not only to one namespace, but the whole cluster? So I may want to, for example, get pods inside pods in null namespaces of the cluster. I want to access resources that do not belong to a namespace, like nodes. Nodes do not belong to a namespace. In that case, in order to apply cluster-wide privileges, we've got another two API objects. We had the role before, now we have the cluster role, which is pretty much the same as a role, but applied to a whole cluster, to all namespaces, to all kind of resources, namespace resources or not. So for example, if I want to now say a set of, against a set of operations over a set of resources, but to the whole cluster. So we can have list and get pods in all namespaces. We can have, for example, persistent volumes, which are not namespaced, which are cluster-wide objects. We can create roles to work with these kind of resources. So that's, as you can see, it's something very similar to the role, but just inside the cluster for the whole cluster. So how do we define this? What's the YAML? Good news. The YAML is pretty much the same as a role. It's just, what's the only difference? Obviously, the kind is different. Role, one is role and another is cluster role. But in this case, it doesn't make sense to put the namespace because it's just for the whole cluster, right? But the YAML is just the same. So, okay, now we have a set of operations over a set of resources for the whole cluster. We need to connect to the third group, the users. And if we have role and role binding, guess what? We have cluster roles and cluster role bindings, which is just the same, to connect a cluster role to a set of users. For example, we may want to that all members of the dev group can read all pods in the cluster, and we may only want that only those that are administrator that belong, for example, to the group SRE can work with persistent volumes, for example. So that's the same idea. So once again, the YAML is just practically the same. We remove the difference. We have no namespace implied, and what we connect in this case are cluster roles instead of roles. But it's just really similar. So let's go back to my user, Jay Salmeron. So now we're going to grant this user access to read pods in all the cluster. So if we go back to being the administrator, we're going to apply now these two YAMLs. First one is, we've seen it before, there's a cluster role, very similar, just to get on these pods. And the other one, the binding, is basically, we're going to grant this cluster role that we're going to create to the user, Jay Salmeron. As you can see, let me insist on this because it's one of the concepts that it's more difficult to understand, but it's just three sets. If we understand that three groups, use subjects, resources, and operations, this goes really smoothly. So I'm going to apply them. I apply the two YAML objects, and now if I go back to my user, so of course I can read everything for the test namespace, but also I can read from the default namespace, even from the kube system namespace. Now I can read, but only read pods from every namespace. Can I do it with services? No, I can't, because I only have privileges to see services in the test namespace. And I can only read pods from in all namespaces, but only pods. So of course I still can't deploy any deployments in a namespace different from the from test. And that's one of the most important things to deal with, to understand in RBAC, these 4 objects. With this, you're going to do pretty much everything. More things about cluster role bindings. This is more for those that want to that have created a cluster from scratch, for example, or those may know that Kubernetes by default already includes some cluster role bindings. For example, system basic user, which basically this is when you try to access the cluster without a proper authentication, this RBAC rule will apply, which doesn't allow you to do, I assume, basically no operation. This one is one of the, we'll go back to this one, but this is just a different case. By default, those users that belong to the system masters group can do any operation on the cluster. So this is the opposite. So in the case of the default Minikube account that we have, a user, that's the group what it belonged to. So what if we created a user with restrictive permissions, but what if we wanted to create an admin user with all privileges? We could create, just like we did before, a certificate request, but with the group system masters. So this user by default will be able to do everything in the cluster. In addition, in the cluster, you can see other cluster role bindings, which are made for the different components of the Kubernetes cluster, the control manager, the scheduler, the proxy, which is out of the scope of this session. But basically, you can see everything using kubectl get cluster role bindings. I'm using the wrong user, so I need to go back to the administrator. And now let's try again. You can see a list of already bindings already there in the cluster. You can see a lot of them. You can see here that they look for components in the cluster, system controller. You can see something about the cloud, etc., etc., etc. But this is how the access and the role-based access control works in the cluster. Then let me also go back a little bit, because it's true that we've talked, I think we understand the concept of subject, we understand the concept of API resources, and we have some intuition about the verbs, about the operations that you can do. So just for a few minutes, I'm going to, so we can understand better, we're going to go really fast to see which operations you need to be able to do in order to execute these simple commands that most of us have executed when working with Kubernetes. For example, for kubectl run, that we know that it creates a deployment, which operations do I need to do to grant in order to be able to do that? Well, this is, as we know, for creating a deployment. But we know as well that deployment will create stateful sets, and not stateful sets, replica sets that will also create pods, right? So do we need to have privileges for all of these resources? We need to be able to create pods, replica sets, deployments. But it seems what it makes sense is that for this command, we need to be able to create, but let's see what. Basically, in order to execute this command, you only need to have privileges to create deployments. That's everything you need. Another one. So if you want to get deployments, this like get pods, this one must be similar to the one that we implemented before, right? But notice that I added also the -w option, which is for waiting, right? It watches constantly the evolution of these deployments, right? So we know that in order to get information for a single deployment, we'll use the get birth. For listing all the deployments, we'll use the list. And also for waiting for this and watching the status, we need these three verbs. I'll continue. So what if we want to delete a deployment? From this list, it looks clear that we need to have to be able to delete a deployment. So this verb, but also not only to delete, also to get, because in order to delete a deployment, first we need to know if it exists, right? So we get first information for the deployment and then we delete it. What else? What if I want to edit a deployment? As you can, this command will allow you to edit some of the properties of the deployment. So intuition tells us that we may need to get the deployment in order to edit it, and also we need to patch it. So these are the verbs that we'll need. And what for this command? For exposing a deployment to create a service. I think I'm saying it, so to create a service, exactly. But also we need to be able to get the information from the deployment in order to see if it exists or not, and then we create the service. These are the two operations in order for this command to work. And on the last one, this is not without some, this one is maybe more difficult. This command is for the entering a pod for some and executing one command, right? For this specific case, of course, we may need to be able to get information from pods. So for the object pods, I need to get it, but also I need another thing that allows me to enter the pod, the containers, which is basically be able to, so this one, to get the pods, and to be able to create this kind of resource. So yes, this may be a little more difficult, but basically, if you go in the API, you will see which operations you need. So basically, you need to, so entering the pod for executing command is like creating an exec element. So it's like creating an execution, which kind of makes sense, actually. So you need to be able to see the information from the pod and be able to create an execution. So I hope with this, we have more ideas of how the verb works. Well, so I'm going back again. So we created a user. We've seen that we're using certificates which contain information about the credentials of the user and the group that it belongs to. Then we tried to access the cluster with this newly created user, but it couldn't do anything. So we needed to create rules that connect the user with some set of resources and some operations. It could be done namespace inside a namespace where role bindings, and in the whole cluster So cluster role and cluster role bindings. And this is where we are now. So this is basically how RBAC works. But I want to go one little step before finishing further. And I want to use Helm, basically. So I want to play a little bit with Helm. So what do we have now? We know that the user can create everything and do pretty much anything inside the test namespace. So one may think, okay, so now I will be able to deploy Helm charts inside my namespace test. Let's see if that's possible. So I change to JSON and I'm going to install one of the Bitnami charts, the DokuWiki chart, in my cluster. Oh, let's go. I can't. Now it's saying here something strange. I don't want to go much into details of Helm, but Helm, what it does is to install a server called Tiller that you need to access in order to deploy Helm charts. This Tiller pod is inside the Kube system namespace. And as you can see, I can access it. I can, because I have get privileges inside my any namespace, thanks to the cluster role binding. However, you can see I can get all the details. However, that's not enough because I also need to do it's not a port forwarding. Some of you may be familiar with the kubectl port forward, which allows you to put to basically just like we do with SSH tunnels to be able to access one container port inside one pod port from your local machine. And that's something you need to do with Helm as well. So I need to be able to forward to my local machine the Helm Tiller ports. So I don't want to go much into details about that. Basically, I need to have a rule that allows me to do this port forward operation. So I'm going to create a role connected to my user, but basically allows you to do the kubectl port forward. If you want more details, we can go then in the Q&A, but I want to do this. I'm going to switch to the administrator, and I'm going to allow myself to do this operation. So now, if everything is correct, now I can access. Sorry,
Javier, just a reminder, we have about 8 minutes left, so we might want to start to transition to questions.
Yeah, 8 minutes left, so I'm going to just go really fast, okay? So basically now I should be able to deploy a cluster. Of course, I can do it. And in principle, I shouldn't be able to deploy in another namespaces, right? So, for example, if I want to install in the default namespace, should fail. However, it didn't fail, which doesn't much make sense because if I, for example, take a kubectl run, I can't do it. So there's something wrong going on here. So if, for example, this kind of command should fail, I shouldn't be able, for example, to deploy a chart in the kube system namespace, right? But the truth is that I'm doing it. So this is something really strange. So if I go back to ask the admin, maybe there's something wrong with Tiller or something. So I'm going to reset. I'm going to delete Tiller because maybe there's something that is not being applied. I'm going to start again if possible. It's taking a bit because I'm having some. Now I'm going to redeploy. And now I'm going to try again. Nice. And suddenly I will deploy it till I get this error. So we don't have much time, so let me go a bit fast. But I wanted you to see that we understand the problem. So I had my privilege well established, but I started using Helm, and I was able to deploy it to pretty much every namespace being JSON my own, which I shouldn't. And I redeployed, and suddenly Helm is failing. So let me go really fast to what's going on. So for those who don't know, again, Helm, what it does is install a pod in your cluster that when you use, for example, Helm install, this will be responsible of rendering the charts and deploying as well to the cluster. So it's not JSON Veron with the one that is deploying to the cluster. It is this pod. So this is the one, there's a process in this pod that is talking to the Kubernetes API to deploy all the different elements. So it's not me, it is this Helm process. So now suddenly it's complaining because it can't. So it's getting RBAC issues after redeploying Helm because it can't access the API. It can't. It's not allowed to do this operation. So really fast. The question is, how do we configure this? Because in the case of human users, it seemed clear. We have a certificate, and with all the data, the administrator signed it, and it worked like that. But what in the case of processes inside pods? So do we need to also create certificates? How does it work? Well, for the case of processes in pods, what we have is an object called service account. So I said before that regular users and in general users did not have a Kubernetes object to create, delete. That was true for all of these kind of users, but the only exception is the processes in a pod. These ones do have a Kubernetes object. Basically, we need this kind of object for pods that need to contact the Kubernetes API, just like the case of Helm. Also, was previously used for storing, for example, image poll secrets, but currently for the RBAC purposes, this is how we deal with access from processes, for processes that want to access the Kubernetes API. So how do we create this kind of objects? It's really simple. It's just we specify a name and a namespace. Under the hood, it will create an API token and it will be stored in the cluster. Notice that before, all the certificates were stored outside the cluster. In this case, with service accounts, the API token will be inside the cluster. And we can use for these kind of service accounts just the same bindings and cluster role bindings as before, as we use with users and groups. See that before I said that we will see another one, right? It was service accounts. Basically, how do you configure service accounts in deployments on pods? Basically, inside a pod, you specify which service account it will be used. So if a pod needs to access the Kubernetes API, then you need to specify a service account inside the pod of the deployment. And if not, it will use the default. And that's what happened when I redeployed Helm, basically. What happened is that when I redeployed, it will use the default service account, and therefore it wasn't able to do anything. So, and just to finish, if we want to deploy Helm with RBAC in our system, we will need to create a service account so that will be linked to the tiller pod. And now, okay, we have the service account, the subject, but we need to specify the set of operations that it can do. So now, what operations will we allow Tiller to do? What it will require? In principle, with Helm, you can deploy anything in any namespace, right? That's what I was doing before. And in principle, that's how most of us use it. So in principle, one would be tempted to use this kind of role bindings. So to take the service account Tiller, say in this case, I want to name it like that, and we will grant the cluster admin cluster role. And if you remember before, the cluster admin cluster role was one of the default that pretty much allowed any kind of operation. And yes, that did work, right? But what happened? Suddenly, as a user called JSON on their own, I was able to deploy in any namespace, breaking the whole RBAC. So you must be really careful when, for example, in the case of Helm, how you configure RBAC, because it's you're creating a hole in your security if not used correctly. So I don't think we have much time, but the rest of basically what I was going to do is just to create to redeploy once again Helm, but this time doing it correctly. So basically, I was creating the service account and applying this cluster role binding. And now, instead of using Helm init, as I used before, I use Helm init, but I specify the service account. So with that, then the Tiller will have the proper privileges. In this case, potentially dangerous, as we've seen before, but was loading, but now it will be able to work. So with that, we've covered all the elements of in RBAC. Subjects, not only regular users, but service accounts, and how to connect everything with roles and role bindings. So I don't think we have much time, so I'm sorry for taking much longer, but basically just to wrap up, I'm open to questions. So
yeah, so what we're going to do, because we're out of time for questions, is we've captured all the questions in the Q&A in Zoom. If you have any left, please answer them in there. Just click on the Q&A button at the bottom. And what we're going to do is gather up all the questions, have you answer them, and then send them back out because we're out of time.
Okay. So I really hope that you enjoyed the session, and it's really helped to clarify some of the doubts and issues that you may have with RBAC. So
yep.
Thank you very much for listening.
And thank you for joining us today to learn something about RBAC and Kubernetes. This webinar recording and all slides will be online later on today, and we'll try to get those questions answered and out to you as fast as possible. And we're looking forward to seeing you at a future CNCF webinar. Thank you and have a nice day.